Hello, welcome back to our CATIA automation tip sessions. My name is Mansu Kim, working for Impararia Solutions. I am a CATIA automation consultant. Today's topic is about the how to use knowledge pattern with the fundamental theories. So let's go start. Actually, here's I already made it to explain how it works. So you see I will once you have the inputs as a reference, let's say we have some panels uh, by the guideline and some sections, and we can create the surface, which is kind of a mesh surface of the panels. And of course, it's parametric, so you can define or change it, and it depends on the project, your shapes. Also, you can bring from somewhere as well. And you can, of course, change the sections. If you have proper dimensions, you can put the dimensions and some constraint in 3D, of course. So just I will skip not define L. Then now, let's say you have the reference surface and the guideline and the section. We starting from here, and now you're creating the user defined feature, which is using the inputs. Input in this case, for creating this segment panel, we will put using the surface and the curve and the two curve more. So we need to have these two curve. It depends on the position. We will keep changing then update. So this is input, and from the input we're creating, let's say from here, creating in the middle, we have an input to curve. Then we can create in the middle curve and project on the curve. Then from here, for each place, you can create a small surface for the intersect line between surface and the face. Same things, ending point as well. Then now you have a two intersection curve, and you can creating the segment. Just finish with this basic simple shapes. Of course, you can create another wings, whatever you want to adding more and more. This user functions will be more. You can decorate more and more. For now, we do with this kind of shapes, and you can create the user picture. So user pictures looks like this. Once your user picture is complete, when you register, you will have the for input, which is we will going to use this name in our script. And output for now is only the shape of this result. Okay. Then now what happens here? I will hide this and show up again the reference. Okay. Then whenever you change the count, so you will create the points and you will create the panels. You see here, like that. So you can create the segment of each panels. Let's change it again. Okay, so now it's 8 panel, 1, 2, 3, 4, 5, 6, 7, 8, right? So how we did that? Okay, the first one, we need to define these two parameters. The first one is I want to measure of the all lengths this is because later I want to change the location of a point by the length. Okay, so total length you can create using the formula editor, like length with curve. So you can just like say measure and the curve length, and you can just double click it from the screen. Then this will capture your knowledge put into the parameter. Okay, so we put it here, total length, and then I want to control the by count. Of course, you can control by the length, whatever you can define yourself. But in this case, just I creating as a count. So now we have a user picture and we have some parameter to control, and we are also creating the geoset to store our output points and panels. Okay, so I created the knowledge pattern 2 times. Okay, so knowledge pattern, look at the knowledge patterns. What is knowledge pattern look like? So here what I define point, because I want to keep point is moving. So I want to create the point first. So the point distance, I define the distance from the total length, which is we defined already, by the divide by count. So you will have the distance of each span, and the first time we going to add is 0 millimeter. So starting from the 0 millimeter, and we'll continue to adding the distance. So you will know which position you will create the point. Okay. Then now you define the integer. First time as 1 until we repeat this loop until the count +1. Because +1, because you need to have the point, additional point, ending part, starting point, ending part. So it should be one more point you need. Then now you define by the functions create or modify the item. You create the point, and you creating the list also here. So while you creating this output, your point will be stored in the list. So then you can use another knowledge pattern. You use this list, continuously working. Okay. Then now you can create the point. This is a theoretical point. Now you can create the physical point. So point on curve functions will allow you to create the point on the guideline, and the starting point is null, and distance add is the first time is 0 millimeter. True. So true direction 0 millimeter. You can create the point here, and we can put the point name point plus to string I. So I is now is 1, so it become a point 1. The name of the point become a point 1. Then now I want to increase the distance add, which is you are using here, because I don't want to create the same location, the point. I need to have a distance. So now distance add equal distance add plus distance. So we have the distance. So we need to keep adding each loop of this distance in the distance add. Okay. So now it's done, and to automatically update, you need to set the automatic update. That means, what is that means? Whenever you change and the update needed for this knowledge pattern, this will update and recreate this point. Okay, of course, when it reduced, it will be reduced. And if count is needed to increase, this will be increase. But the connectivity for the next connectivity is still working. So this is how we control the knowledge pattern, the point. And the next step, we want to use this point to instantiate the panels. See, so this panel, we need to have 4 inputs, if you remember. So first input is the guideline, and the second input is the surface, and third input is point 1, and the fourth input is point 2. So imagine that this will be the first panel, and this will be a second panel, and this will be a third panel. So continue until the end. So this is a theory. We want to instantiate our user picture template. So when you look at the knowledge pattern, it looks like this. To automatic update, mode I selected automatic update, and creating the list. So this list will also control the outputs. And now we can write some small script to repeat. So define the op panel. What is op panel? Is this UDF in this case, and define the integer to how many times you repeat. So I, then the how many times until the list of this count. So in this case it's 9. So you will continue to 9, but this time you need to remove the 1 time, or because the last time is the 2 set and you should be finished. So I put it here -1. So it's not 9 times, but it will be loop in 8 times. And the panel, and use this function create or modify template. So we're going to use the UDF panel, which is here, UDF panel, and we store in the list here, and I, which in the list is I count. So the first in the list will be the first UDF, the second will be a second UDF. Okay, once you define a panel, and now time to set inputs. So a panel set attribute object, surface, curve, point 1, point 2. So we know this one is this one, and the guide curve is this one. And now the point. This is the important part. So the point came from this list. We don't want to click directly because this count will change and disappear. Instead of that, we're using the list and the get item I. So I means its first time is 1, and the second time it will be 2. So it will be increased. And as the last input, the point 2, input point 2, that will be the same like this from get item I. But in this case, I want to increase more 1 point, so it will be a second input. So first input, second input. The next loop will be the first input, second input, like that. So it will be repeat like this. After finish your template, we commenting ending of the template. That's it. Then now you can change the count, and you can, so for example, you can change the guideline, some things different shape, or even you can recreate. Okay, I think I will make some irregular shapes. Just want to make sure this want to be a tangent. So I double click, and you can create the tangent line. Then now you can make the coincidence between two lines, this and this, and the parallel. Okay. So now you can create the shapes. The once you need to update, this will automatically update all the outputs like that. And also you can change the section, of course. If we change the totally different shapes, also let's try some this kind of shapes. Okay. Okay. And yeah, in this case, I'm making two big sections since it's only until here. So now it will be a good chance to see the how to update your user picture. So let's look at the user picture. And it seems this coverage is not enough. So I will just modify a little bit more. Maybe, oops. Instead of 5,500, I will make 1,000. And then I will make also symmetry. Okay, so this size will cover, and here too. Symmetry. Symmetry. So now the shape will covers all, and then we need to update the UDF. So changing and update your component, and then click OK. Now UDF is updated. Then now you need to just repeat the UDF. So all you need to do is just delete. Then because the automatic update, this will recreate by this knowledge pattern. So the result is look like this. Okay. Yeah, that's all for today. I hope you get an idea how to use the CATIA and the EKL for the startings, getting the idea. Like this way, you can create your repeatable task. You can reduce your repeatable task. Hope you enjoy. Have a good day. Thank you.